Hello, you guys. This is Miss Miller, bringing you a video today. Just wanted to say I miss you guys. Kind of weird not being in class. I hope you guys are staying safe and doing okay. The first thing that we have in Google Classroom is dealing with right triangle trig, the sine, cosine, and tangent. So I wanted to do a little quick introductory video, and then I'll add some other videos that go a little more in detail. After your assignment is due on the right triangle trig, then I will post a video that goes through each one of those questions. I might have to do them in separate videos because I can't do long ones on my phone. All right, so let's talk about right triangle trig real quick. So if I were to draw a right triangle, okay, and we're just going to keep this simple for now. We'll call this angle A, B, and C. All right, so if I'm looking at this, if I'm looking from the perspective of angle A, which is right here, this angle, okay? If I'm looking from A, this becomes my opposite side. Okay, that makes sense? All right, and this is always going to be my hypotenuse. That never changes, okay? Everybody good with that? I'm sorry, I'm trying to write quickly. And then this would make this my adjacent side. Okay, everybody good with, if I'm talking about from angle A, that's opposite, hypotenuse, and my adjacent. Everybody good with that? All right, so now let's talk about sine, cosine, and tangent as it relates to angle A. Okay, so sine, we label it S-I-N. A lot of people call it sin, but it's sine. Okay, we'll talk about that later. Sine is always equal to opposite over hypotenuse. Okay, so if I look at this particular thing, if I said sine of A, angle A, I look up here, it says opposite. So what's opposite? This side, BC, right? So I'd say BC, whatever it happens to be, over hypotenuse, which in this case, my hypotenuse is AC. Does that make sense? Now, a lot of times I'm going to have a number there, and we'll look at that in just a minute. Okay? If I was going to say cosine of A, cosine of A is adjacent over hypotenuse. Okay, adjacent over hypotenuse. So if I look back, let me do this. If I look back at cosine A up here, it's adjacent. Adjacent would be AB over hypotenuse. Hypotenuse is AC. So I'm going to put AC here. Everybody okay with those? All right, and then the last ratio is tangent. And tangent is equal to opposite over adjacent. Okay, so back to tangent of A. So if I look, opposite is here, BC, right? Over adjacent, which is here, AB. Okay, everybody good with that? All right, question sine, cosine, and tangent. All right, now this will change a little bit if I go from angle C. All right, so if I come up here and instead of referencing angle A, I reference angle C. Okay, now this still stays my hypotenuse. That's my longest side, always will be. But this and this now will swap. Okay, so instead of being opposite here, this would become adjacent. And instead of adjacent, this would become opposite. Okay, so now if I come down here and I say sine of C, now I got to change it a little bit, right? My hypotenuse is going to stay the same, right? That part won't change, but this will, right? But instead of BC, now I want to put AB, right? So I'm going to come over here and put AB. All right. And then over here, cosine, adjacent. Now adjacent is BC, right? So I'm going to have to erase this and put BC. But my hypotenuse is still AC, right? That has not changed at all. Okay, now if I come over here, oh, let me change that to cosine B or C so that makes sense. I don't want to write it wrong. And then over here, if I change this back to tan of C, opposite over adjacent, these are actually going to swap, aren't they? Because now opposite has become AB, right? So AB would go on top now. And adjacent is BC. So I'm going to put BC down here. All right. So now if you notice, I can't do sine, cosine, or tangent of angle B because that's the right angle. I can only do the two corners up here, okay? I can't do B. All right, so I'll let that soak in. I'll do another video here in a few minutes with, oops, trying to go out. I guess as far as I got. I'll do another video here in a minute where we start applying these sine, cosine, and tangent ratios to actual problems where we have to find missing side lengths and angle measures, okay? I hope this helped a little bit, a little quick review.